This is another edition of 3D Printing News Unpeeled. So first, it's courtesy of 3dprint.com. So first, we're looking at CYBE, which has a gantry 3D printer, and they're attempting to print a four-story building. There's a small little apartment building at Lab 040 in Eindhoven. Eindhoven's a 3D printing hotbed already for construction, given the work that the TU, Eindhoven, the Technical University of Eindhoven, has done on bridges and other structures, and given that Weber B-Mix has a 3D print factory there as well. CYB is trying to do something similar, as in they're trying to 3D print in the factory where they control the environment better and then ship the components to the construction site. One could easily see how this could be very advantageous because you could do that factory at a place where materials are cheap or energy is cheap. And what you can also do is put the building on kind of a production line and have people install the kitchen or put in the tiling or put in the wire and all that at that site and then ship that thing to the final construction. I think this is something that a lot of people aren't really considering, but this is happening with cruise cabins and a couple of other modular buildings as well. But we can't, it could be possible at one point to take, for example, an entire building, which including the bathrooms and everything, the kitchen cabinets and everything made in them from India, and to ship that to the Netherlands, for example, to have it installed there. That could really change things. But it's a bit early days for that, but these are the kind of things that 3D printing construction could change. And this is a very different model than, of course, 3D printing on location, which is super hyper local, and it's the other way. Anyway, CYB is trying to do the print on in the factory and then ship to the consumer kind of thing, the flat pack houses kind of approach. And it says that it can achieve lower emissions and lower costs by doing this. This is a sign of the maturing industry in 3D printing construction. There's a ton of people racing to make multi-story buildings with 3D printing construction, which is very difficult because you need reinforcement from steel or reinforcement from strands or something like that. And so there's teams in Saudi Arabia and other places trying to be the first to really make multi-story buildings. So sign of the maturity of this and also the dangers, because now we're looking at structures where we're talking, multi-story is much, much more difficult than just making a shed somewhere or something. So this could also up the danger quotient and the level of safety required for these kind of things. So that's very exciting new development. So what is also very exciting is hypersonics. I'm very, very into hypersonics, and I think it's one of the biggest developments, the biggest things ongoing in the world today that are not sufficiently being considered by the news media or by people in general, especially if you work in 3D printing. So hypersonics is any kind of vehicle. Some people say they're hypersonic missiles or hypersonics. Other people think it's a hypersonic glide vehicle. Generally, I think we need to agree that a true hypersonic vehicle is something that can go 5 or 6 times or more at the speed of sound in a controlled way, and can be reusable and do kind of a directed flight in a kind of repeatable, reusable kind of way consistently. Now, why is this important? Well, we'll get to that in a bit. What's going on now is that the US is starting its Growing Additive Manufacturing Maturity for Airbreathing Hypersonics. That's a Gamma H project. This is the idea to encourage manufacturing companies and materials companies to submit tenders and offers and things to build parts for hypersonic glide vehicles. This is being run by the National Security Technology Accelerator, also called NSTXL. And you can essentially, as a business, submit proposals for developing these components. And their idea is to rope in small businesses, small to medium businesses, businesses that are not traditional defense contractors. They're really trying to activate the economic and inventor prowess of, I think, particularly American companies in making this whole supply chain possible. Now, why is additive so important for this? Hypersonic vehicles are under a lot of pressure. A lot of really high performance components have to be made, and very high performance materials, which are often difficult to machine. By optimizing these components and saving weight, we can make better vehicles, and we can make vehicles that actually would withstand the pressures of hypersonic flight better than conventional materials. Also do this in a more expensive way. So all the advantages for making using 3D printing for rockets also apply to hypersonics, integrating components, saving weight, optimized geometries, optimized part properties that we can change, things like that. So additive manufacturing is going to play a huge part of this. So this is something you should be involved in. If you're a high quality, high end manufacturer, if you're involved in materials, try to be involved in this, because this is going to be a bonanza. Now, This effort is also being held by the U.S. Navy. You can submit proposals to it before December 12th, so get your Christmas presents in early. And it follows on from other attempts by the United States that are, well, these are overt attempts. There are there's much more going on they don't tell anyone about. But the ones that have told everyone about is, for example, Raytheon just got a $1 billion order, I think in September somewhere, on the Hypersonic Attack Cruise Missile, HACM. Which is an ex-DARPA project. Lockheed, back in 2018, got an order for the ARW, an air-launched rapid response weapon. Those both are kind of weapons that are attached to a B-52, the ancient B-52 bomber, and then are air-launched. Boeing did some early work on this, and the X-51 and other projects in the 2010s, and then did the HyFly project, HY-Fly project, which was not successful, to put it mildly. And then there was the HyFly 2 project at Boeing, which is now being funded, which could give them get their skin in the game again. So the U.S. is doing a lot to stimulate its large companies from making into making hypersonic, but also would like to go a step further and help establish a supply chain for small to medium businesses that could be very innovative. And why are hypersonics important? I mean, they're the ultimate high ground. I've said this before. What you have is essentially a tactical satellite where you can put this thing where you want it to be in a very short order. And you could put a sensor package or you can put a kinetics package wherever you want, and the other guy cannot do anything about it. Right? If you're talking about a missile type of capability, you could, through the speed and through the fact that it doesn't have to necessarily go over the horizon like an ICBM, where you can kind of see it coming. It might be very fast, but you can see the IBM coming because it's coming in this nice little arc towards you. The hypersonic missile could evade this and go all sorts of different paths and all sorts of different altitudes to evade any kind of existing warning system. So this means that in a nuclear sense, or a first strike sense, in a conventional munition sense, you could have a first strike capability akin to the U.S. when it had a stealth aircraft going to Iraq. You could have a strike capability that the other guy has no response for. And in case of a war somewhere, you could put a jamming package or a sensor package above their capital city. They can't do anything about it, right? And then on top of that, what you could also do is put a mission in there that could strike them before they can hit you. And it can go so fast that it'd be very difficult to track this thing and very, very difficult to do anything about it, even if you could track it. The rhetoric around this is going to look at kind of like looking at this as being a little bit different than before. You're getting this kinetic ability anywhere in hours. So the conventional munition has improved, but also, potentially nuclear payloads as well. So you're getting the rhetoric the U.S. is now spouting things like deterrence by denial, right? Where you're saying, wait a minute, there is a scenario here where we can stop the other guy from getting a first strike, or we ourselves have a new first strike capability that's beyond, that doesn't have to take this 20 minutes as ICBM has to, but it could be much faster. So this is potentially a very destabilizing thing globally, especially now the United States considers China to be a near-peer adversary, and also considers China to be ahead in hypersonics. So this is very dangerous. It's very strategic for the United States of America. The U.S. is doing a lot to stimulate its very close allies in Australia and the U.K. to develop hypersonics as well. It really is putting a lot of money in this and a lot of effort because, like I said, it's the ultimate high ground. And so to me, this is a very, very important development. I really don't think that the media and generally do not have enough appreciation of how important this is, to have an ability to listen in or jam or interdict the other guy while he can't do anything about it anywhere on the planet, right? Within a very short amount of time. This is an incredible ability, and really make everything else. It's like it's like everyone has prop airplanes, and all of a sudden you go the jet engine, but only a lot faster, or the differential is much faster than before. So this is huge. And there's also a bunch of commercial opportunities as well, and kind of tactical satellites and other kind of commercial missions that could fall onto this. And also a lot of these technologies and optimizations in 3D print technology and these materials to withstand these pressures and heat, they could be reused for spaceflight as well. So that's a very, very exciting program. And if you are doing anything in precision manufacturing in the United States of America, I would advise you get in on that. So the next thing is from Perron Wei and Dr. Emily Pencer and many other people at Texas A&M. And they did a paper called 3D printed CO2-based tri-block copolymers and post-printing modification. They're all from various departments at Texas A&M University, and they did a paper for Angewandte Chemie. This uses texotropic ink, carbon dioxide, and table salt to 3D print a structure using direct ink write. This structure is then washed, the salt is dissolved, and you end up with a rather porous plastic structure. This can be used as a polymer can, but it can be kind of, well, it can degrade much faster than other structures could, right? And what is the exciting bit here is it could have probable or programmable degradation. So you could program it to a certain extent, right? To have certain tunable properties generally, which would be really exciting. And you could also program it to degrade within the right conditions or within the right material, within the right time frame. So theoretically, you could make a material that's really great as a plastic bag, but 2-3 days hence would degrade very quickly. So these kind of, or in a particular substance. So these kind of things, like really, I like this because it's not only green, but you can understand there's a commercial ability here for a plastics company that maybe doesn't care about the environment, but would spot this as a way to capitalize off of making new material. So to me, this is kind of like a, if we're talking about the carrot and the stick, this is a very stick way of motivating polymer companies to come up with better solutions for the environment. And yeah, so in that sense, I think this could be a very potentially very long-term, very new paradigm in plastics consumption. Now, most of these things never end up making it to market, and most of them take a long time to commercialize if they do. So don't get too hopeful about this, but it's nice to see that people are working on these kind of opportunities. So it's also nice to see that direct ink write, DAW, is so versatile and it's being used so often in research now. It's crazy how much stuff is coming out on this. It's becoming kind of like a very, very well used production method. Anyway, so thank you very much for your time today. My name is Joris Peels, and this is another edition